Hello everyone, good morning, afternoon, or evening, depends on when you're watching this video. But today, the week 2 programming class I cannot attend it because I'll be on a plane. If I could, I would do anything to be able to attend this class, but I won't be able to, sadly. So I've recorded a video that's taken me a pretty long time to arrange and write the script for, and I really hope that you guys can reference to that video and rewind and forward and look at the parts that you've missed. And I think this format might help a lot more with something like that, especially something as complicated as programming and object-oriented programming, which is like probably the hardest part of first learning Java, and then we're touching on that today. So make sure to pay attention, even if you have prior Java experience. This is still a very, very important video to fully watch. Hope you guys have been having a great week, and let's start off with object-oriented programming. Hi everyone, so today we're going to be covering week 2 of the curriculum. If you want a real review of what we're going to be covering today, it's right here. So first we're going to be covering what object-oriented programming is, then we're going to be touching on classes, objects, and methods, then if statements, if else statements, and then finally loops. Now first we're going to discuss what exactly is object-oriented programming. Object-oriented programming is when you use things called objects to store data, to perform certain functions, etc., etc. So let's start with the basics of object-oriented programming. A class. So let's create a new file here. Let's call it cat.java. Let's create another one called dog.java. And finally, we're going to create a file named animal.java. And we're going to make this a class. So the first part of what a class is it's a data type. It consists of certain data and functions. So these functions are special, in which instead of being able to access like anywhere, like with system.out.print, it has to be accessed by calling it onto an instance of your class. That sounds complicated, but it's a lot easier to understand once we start with examples. So let's implement our animal class. So what does an animal usually do? Well, I mean, an animal talks, right? Like barks if it's a dog, it meows if it's a cat. But overall, it's kind of like talking, with big quotes around talking, of course. So let's implement a talk function, or in this case, because it's inside the class, it's going to be called a method. So here we go. We're going to have our public class animal. Then what we're going to do is we're going to type out public, because we want this to be publicly seen. Then we're going to be typing out void, because it's not going to give us anything, and talk. That's going to be our function, our method name. So notice how in previous functions, like we see in week 1, do you see how we have static written in the front here? There's no static in when we go back to animal, there's no static on this function because of the fact that it's not a function, it's a method. So if we go back to here, we can take a look. We have our method talk. And let's say, let's see, how do we want it to talk? Go like system.out.println. Hi, I'm an animal. I mean, kind of makes sense, right? We don't know what animal this represents. We just know that it's an animal. So we just say, hi, I'm an animal here for its talk method. It's not realistic. This is an example, of course. So now we've written our talk function in our animal class. That's great. Now let's go back to our cat and dog classes. Now, most people would consider cats and dogs to be animals, right? And we see that in the animal class, it can talk, right? You can see it like talks. So what if we could of course just copy and paste this into the cat area. But then imagine doing that for hundreds of methods. That would become pretty hard to fully implement, of course, right? So instead, Java's done this amazing thing utilizing object-oriented programming, where what you can do is you can type in the keyword extends, then you type in what we want to extend from. What this effectively does is it will copy paste all of these functions into cat without us having to type it. Way easier to use than copying it, and every time you make a change here, you can put it here. You have to put it here. So this extends animal, but I don't want the cat to say, hi, I'm an animal. I want the cat to be able to say meow, right? So if we do public void talk, public void talk, and we type out meow, now it can meow, right? That makes sense, fully makes sense. So now the cat can meow, and the reason that we had to write this out is because we're altering it. Let's say we had another method here that says am I alive, just an example, and it prints out yes. If I wanted to call that method onto cat, I wouldn't have to write this out because I'm not changing what it is. I mean, cats are alive, right? So because I'm not changing this method, I don't have to rewrite it here. So what this extend keyword allows us to do is we only have to rewrite the methods that we're changing from this class that we're extending. So let's do the same thing, and let's do it for the dog class. We put dog extends animal, because dogs are animals. And here, instead of saying meow, we're going to say woof. Wow, that's great. So now we've got these classes, but you can't run this class. There's no public static void main. So what do we do with the classes now? Well, let's take a look here. So right now, I'm in week2.java. And let's take our cat, dog, and animal. But how do we add our cat, dog, and animal into here? Let's take a look at week 1's code. Do you see here how we define the object's type? So like string str is equal to hello SOR. So we can do that same thing because animal, cat, and dog are all effectively types as well. What we can do is we can do animal, random animal is equal to, well, what do we do now? For the rest of them, we just like wrote their expression out. Like we had the quotation marks here for the strings, and for the numbers, we just wrote the numbers using our keypad. So how do we write a new object? Well, if you look closely at the code that we wrote last week, we can look at an example of how this is done in Java. So here, when we define the scanner in week 1's code, we use new scanner. What that effectively does is it creates a new object based on this class. So let's go to week 2, and animal random animal is equal to new animal. Ta-da! Now we have our animal. Now we can take a random animal, dot, and you see here it has am I alive and talk. So if we write random animal.talk and then we run this code, if we run this code, it says, hi, I'm an animal. That's great. Now let's try this thing with cat. So cat, cute, orange cat is equal to new cat. And we can do cute orange cat dot talk. And we run our code again. Meow. That's great. So you can see how that translates. But maybe you don't understand how. Maybe like you're just saying, oh, how do we know that the extends actually takes this? And because we're implementing it again here and we're changing it. So if we take a look here and we take both our random animal and do am I alive and cute orange cat dot am I alive, and we run this code again, it says yes for both of them. If we go back to the cat file, we never had to write out the function that's in the animal file. It just automatically copies and pastes it into here without it even being written. That's great. Awesome. So now you see how the basics of objects work, right? But you see these functions, talk and am I alive. If you do am I alive, it's not there, right? This doesn't work. If you look at week 1, how we have print and add number, right? We don't have to put it like dot object, right? We just write it out and it works. So that's the difference between a function and a method, where you have to have an object that you're referencing to run it. Now you might be wondering, well, what's the point of all of this, right? So if we run this function here, why does it need to be in this object? Well, let's give an example, right? So all animals have names, right? So we can put here, let's say this, I mean, we don't have a name for this animal, right? So, but for the rest of the animals, they are. So for now, we can put a placeholder name as like animal, right? But how do we give this animal that field, right? Where it has a name field that can be changed depending on like the object, right? So here we'd put public string name, just like that. Confusing at first, but all we're doing here is we're defining what fields this class has. So what information is stored inside of the object. Now, how do we set this? How do we change the name? We have to use something that's called a constructor. So, as the name suggests, it constructs the object that this class is reliant, that this class is kind of the template for. So, if we do public animal, we can set our name to equal anything we want, right? Well, obviously, you have to name that animal. So, what we do is we write in string name, right? You see that? And now we're going to do this dot name is equal to name. So we're taking this name, the name given here, and we're setting it to this object, the object that we're creating the name. So now, if we go back to our code, we see this error here. What in the world is happening? Animal is undefined. The constructor animal is undefined. That's because we never gave it the name. So let's name it Jake. And now our animal's name is Jake. You can't see this like normally, but if we debug Java and we put a breakpoint here so we can see what's going on, if you could see here, we're given like a bunch of information. You don't have to worry about that for now. But if we take a look at here, you have animal, right? And then if you right click this and you click and evaluate console, you get that. And if we do random animal dot name, because we want to read the name, you can see it's Jake. Yay! That's the animal's name. And we can see that here as well. When we call random animal and we look at the fields inside, it says name Jake. So that field is there, and you can access it at any time just by doing random animal dot name, right? Now we could do that exact same thing with the cat. So now, if you don't notice, like you can put, if you do like cat, qorange cat dot name, it's there, right? That's great. So let's see what the name is. So if we click this here and we put a breakpoint here, we can save it and then debug run it so we can see what's happening. Oh no, we got an error. So the error right here is exception in thread main, unresolved compilation problems. So what does that mean? If we go back here to cat, implicit superconstructor animal is undefined for default constructor, must define an explicit constructor. Now this just sounds like word soup when you first take a look at it, but if you analyze what it's trying to say, it suddenly makes a lot more sense. So the constructor for the extension, which is called the super in this instance, is undefined. So It's undefined, and you'll have to define an explicit constructor. So what that tells us is if we're extending something and we're adding and we're inputting a certain argument into it, right? And we do stuff with the argument, for every class that extends it, we have to put that same argument there. So here we'll do that same thing that we did in animal, where we did public animal. Now we're just going to do public cat, right? And obviously we want the string name, right? And notice how we don't have to rewrite string name here. It already knows that there's a string object stored inside the cat object. So now here, what's the error here? Look at this. So it's telling us it's still undefined because we have to do super. So what super does is it will take all of the arguments that we passed in through here, and it will put it, and it'll run this code here. That's all it does. So instead of having to rewrite this code, right? Imagine if this was like 200,000 lines long, like all the way like that. Pain in the ass to just copy and paste every time you make a change. What super does is it'll automatically just go back and call this code. So now we go back to our cat and we type in, I don't know, Garfield. And we run our debug code again. And we can see here, we have our cute orange cat, and we highlight over it, and we see its name, Garfield. And if we highlight over random animal, we see that we have no name for it because we removed the name from here. Got that? Okay, so now we've found out how we can set certain variables to be stored in these objects, how we can have different functions, and that's all fine and dandy. And that's pretty much the basics of classes, objects, and methods. Obviously, there's going to be a lot more complex topics in object-oriented programming, which we'll touch on next week. I'll send over a video that I highly suggest you guys watch about more of the finer details of object-oriented programming, and just as a quick refresher, because this is easily one of the hardest topics in programming, because it's not very intuitive at the start, but as you develop your programming skills, it becomes more and more useful by the day. Now there's one final thing I wanted to touch on in our cat class, and that is utilizing this thing in our methods. So we're at our talk, right? And maybe the cat is anthropomorphic and can speak like Garfield does, right? I mean, we named it Garfield after all. And we want it to be able to say its name, right? So what we're going to do here is we're going to take a look. Here, it says meow in the talk class. And now we want it to say its name. So if you want to refer to this object that we've set in animal here, what you can do is you can do this dot name, and you're calling the object dot name. And for specifically these fields that are stored in the object, you don't actually have to put it in here. These outside arguments aren't required because it's inside the object. And that's a benefit of using methods instead of functions, because you're already given a couple objects to work with, and that makes it a lot less janky and a lot easier to read. So now if we take a look at this code and we run it in normal Java, meow, Garfield, that's great. So it works, right? You can see here, it says Garfield here. And if we copy paste this and we name it Black Cat, and I don't know, Black Cat, not very creative today. But if we do blackcat.talk, we can see that meow black cat and then meow Garfield here. So that's how you use fields from your object inside your methods. Now we finally get to touch on if-else statements. So what is an if-else statement? So what an if-else statement basically is it allows us to have certain conditions on whether to run code or not. So let me show you with an example. Let's separate this out a bit and make it separate from the previous object-oriented programming section. So let's say we ask the user, hey, do you want us to print out a certain number, right? If you want to print out like the number 5, just an example, of course. So, depending on the user input, we're either going to print out the number 5 or we're not going to print anything at all. So, let's try to implement that. So, we're going to do scanner input is equal to new scanner, and then system.in. And now we defined our input. Now we're going to do, system.out.print here. Instead of println, we're going to write out print, so it doesn't enter with a new line, and it only enters in the same line. A lot easier for the user to input their value. So what we're going to do is we're going to type in, hey, do you want to, if you want to print out, I can't type today, you want to print out the number 5, or 5. And this is going to print, and if we do input dot next string, or next line, we're going to get a string. So, and this is going to be our input from the user. So if we, let's comment this code out temporarily, and if we run this, it's going to print out, and we can put y, but it doesn't do anything yet. We still have the input here, right? And let's make this easier for the user. Let's specifically state that it's either yes or no. So now, where do we go from here? We know it's a y, and we know it's an n, but how do we take that y and n, right? And then depending on what this is, we determine what we're going to do. Well, that's where if-else statements come in. So we can type out if in is equal to yes, then we're going to print out 5. Else, well, we don't want it to do anything, right? So we're going to leave that blank. Now, if we run this code, do you think it's going to work? I mean, the logic looks fine, but hold up. Let's type this here. And as we see, we get nothing. What in the world just happened? The logic is fine. It looks okay, right? There's this very interesting quirk in Java, however, where for objects that aren't numbers, like floats, integers, and doubles, you always use dot equals. So we do dot. Now, it's just the way that Java works because it's object oriented. So we do dot equals, and we put in our string here, right, string y. And now, if we run our code, and we type in y here, wow, it prints 5. That's great. So that's an if-else statement. It'll take this condition, and if this is true, then it will do the action here. And you can put the else statement if this statement is not true. Now let's take a look here. How does Java know if a statement is true or false? Well, for that, it uses a Boolean. So a Boolean is another primitive type like integer, string, and double, where it's effectively just true or false. So you can create a function that returns true or false by making it return the Boolean class, the primitive. So that's effectively what dot equals does. It compares the strings and it outputs a Boolean. And that's also what the equal sign does. It's the exact same thing, except it's less transparent. So now we have our code for an if-else statement. And finally, we're going to cover loops. So loops, all loops do are it repeats a certain segment of code a specific amount of time. So let's look at, there's two types of loops. There's basic loops and advanced for loops. So a loop is started off with the keyword for. So for, then we're gonna initialize our counter. So int I is equal to 0, and then we're gonna say how many times this program is gonna run. So 5 times, and then I++, which means every time the code runs, how are we gonna manipulate this variable? So if you wanted, you could make this I plus or equal to 2, which means it adds 2 to I every time. But then then this code would finish a lot quicker, because all the for statement does is it will keep running the code until this is true, right? So it's effectively if I is smaller than 5, then code, else go back, if I is smaller than 5, code, else we're gonna leave, right? And this just keeps happening in a loop forever and ever. So now we're going back here, right? And we just want this to be plus plus. So I++ means it just increments by 1 every time it's called. And let's say we want it to print out hello, right? So now if we run this and we go through this, it runs it 5 times on the dot. That's great, right? Let's say we want to print out I. We want to see how many iterations it is. We click this print, right? And 0, 1, 2, 3, 4. This 5 is just from the code up here. Let's comment that out right now, just to make it easier to look at. What if we want to create a little pyramid, like where we have 1 here, then we have 2 here, then we have 3 here, then we have 4 here, with a for loop? I'm going to give you a couple seconds or even a couple minutes, however long you guys want, to try to figure the solution out yourself. Okay, so now if we take a look at our code, we might figure out, hey, maybe the string class has something that we could use to help. So let's write out system out, right? Delete this one, and let's see. So we have let's write a string here. So, hold up. We have a string dot is equal to here, right? We could say dot. Maybe let's see something that allows us to repeat it here. Scroll. Repeat. That's amazing. So another easier way to do this is you're going to hold control and then you're going to click onto the string. You're going to control F and then type out repeat. It allows us to repeat. So now we're going to do dot repeat I times, right? And if you wanted, what you could do is instead of writing out dot, you could just write it like that. You don't have to write it as a completely new definition or variable. If we run this code, ta-da! Beautiful. Let me know through DMs on Slack or messages or Discord how you accomplished your solution and whether it was similar or not. I'd love to take a look at your solutions for this. So that's the basics of a regular for loop. Now, advanced for loops we'll be covering later in week 3 once we start covering arrays and array lists. But for now, these are the key components that you need to know about: loops, if-else statements, classes, objects, methods, and object-oriented programming. I'll be sending, along with this video, I'll be sending another video by a really great resource on YouTube on what exactly object-oriented programming is, as a quick refresher if there were some things that you wanted a different view on. It's been great talking to you. Sad that I wasn't able to come as I'm currently on a flight, but if you have any questions, feel free to message me on Discord, Slack, or iMessages. Anytime, I'll most likely be available. Alright, see you guys next week.